Hello everyone, today I am going to give you a brief tutorial on QIC. QIC is Quick UDP Internet Connections. So this is the demonstration video for SIT202 Networks and Communication Task-6.3HD, my awesome tutorial. This is for those who have a basic understanding of other protocols like HTTP or TCP. First, we will look at the introduction and the need for QIC, its advantages and disadvantages, and network applications that uses scalability and much more. First, we have the introduction. You can see that QIC is a relatively new transport layer that is developed by Google. It is designed to provide low latency, secure, and reliable communication between clients and servers over the internet. Unlike TCP, which operates over a reliable connection-oriented stream, QIC uses UDP as its underlying transport protocol, enabling faster data transmission and reduced latency. As in the diagram, you can see that there is a delay of 1 RTT, which is round trip time. First the client initiates a client hello, and if the server rejects it, as you can see, the server rejects it, then it completes the next hello in the next step. The data is transmitted and a server hello is received and data is acknowledged. Some data itself have previously visited a website. We can have a 0 round trip time, so the hello process is not there. And we directly complete the client hello and send the data, and the server also sends hello and some data. QIC also includes features such as encryption, multiplexing, flow control, which we will discuss in detail in the next slide. As a result of this feature, QIC has been increasingly popular and is now supported by almost major web browsers and servers. So, what was the need for QIC? The need for QIC arises from limitations in traditional TCP. And the TCP was designed in 1980s when the internet was very different from what it is today. With the increasing use of mobile devices and the demand of faster, more reliable and secure connections, TCP limitations have become more apparent. QIC addresses these limitations by using UDP, which allows for faster data transmission and reduced latency. By including advanced features such as encryption, multiplexing, and flow control, these features enable improved performance, congestion control, and reliability, making QIC, or we can say quick, an important protocol for modern web application and services. Now we will be looking at functionalities of QIC. Some of the major functionalities include multiplexing, which we mentioned earlier that we will going to discuss in detail. Multiplexing allows multiple streams of data to be sent over a single connection, reducing the number of connections needed and improving performance. The second is encryption. QIC uses an encryption to protect the data in transit, providing better security and privacy than TCP. The third is flow control. QIC includes flow control mechanism that prevent overloading of the network and improve reliability. It improves reliability. Also, fast retransmission is a feature of QIC. And QIC can quickly recover from lost or corrupted packets, improving overall reliability and reducing latency. Some advantages and disadvantages include: first, we will be discussing advantages: reduced latency and faster data transmission due to the use of UDP, and advanced features such as multiplexing, improved security and privacy, which we discussed earlier, better performance and reliability through flow control and fast retransmission, and seamless handoff and handshakes between different network interfaces or IP addresses. But like every solution, it comes with own set of problems. It also has some disadvantages like compatibility issues with some network devices and firewalls. Higher CPU usage due to the encryption and decryptions of packets, limited adoption and support, although this is rapidly improving, and complexity in implementation and debugging. Next, we are going to look at the network applications where QIC is used in the current scenario. The first network application is web browsing. As you know, many major web browsers including Chrome, Firefox and Edge are web browsers that are used by most people on daily basis. In fact, a significant percentage of Google traffic is now served over QIC. Second is video streaming. Services like YouTube and Netflix are increasingly using QIC to deliver high-quality video content with lower latency. I have explored YouTube and captured some QIC packets through Wireshark, which I will discuss later in the slides. The third one is online gaming. The emerging companies are now using QIC to reduce latency and improve performance for multiplayer games. Mobile applications, and QIC is also well suited for mobile applications due to its low latency and efficient use of network resources. Some potential security threats associated with QIC include: first, denial of service, which is also called DOS attacks. Attackers can use various methods to flood servers with traffic, causing them become overwhelmed and unavailable to legitimate users. The second attack is a man-in-the-middle attack, which is also called MITM attack. Hackers can intercept and modify data in transit, potentially stealing sensitive information or inserting malicious code. And the third is protocol downgrade attack. This third attack, in this, attackers can force the client or servers to use an older or less secure version of QIC or another protocol, making it easier to exploit vulnerabilities. Fourth is packet interception and modification, potentially stealing sensitive information or causing errors in the data stream. The fifth is timing attacks, where attackers can use timing information to infer sensitive information such as the size of the encrypted packets or the timing of the specific events. The next one, we will move on to the scalability of QIC. QIC was designed to be scalable for large-scale deployments on the modern internet. It achieves this by utilizing advanced features such as connection multiplexing, flow control, and congestion control. Multiplexing allows multiple streams of data to be sent over a single connection. These details we have discussed already, but the congestion control mechanism and flow control prevent overloading of the network and improve reliability. QIC also have some features like connection migration and adaptive rate control, which we have a good share of knowledge about till now. In the end, we can say these features make Quick a scalable protocol. It is well suited for large scale deployment on the modern internet. So let's move on to the much awaited Wireshark analysis. In this, I have attached a screenshot of analysis of a website, which is youtube.com. which shows the QIC packet layer analysis. We can do this by running Wireshark, then logging on to the YouTube. Here I have captured some packets from youtube.com, or you can say it's a Google product only. We will be discussing these packets in detail. You don't have to do much. You just have to open Wireshark and start capturing the traffic from clicking on this button. And after some time you can press pause, and after that you have, in the display filter, you have to type QUIC and click on apply button. This apply filter button, then you can see the traffic of QUIC protocol. Look for the packets related to desired application in this YouTube. Let's analyze each packet. So packet 402, initial packet, as you can see the number 402 and time. So the source was my IP address and the destination was website IP address. So the initial packet payloads include in crypto and ping. Packet 403, 405, 403, 405 and 404. These two, as you can see in them, the 0 RTT packets indicating early data transmission with the same destination ID, DC ID, right? So packet 407 then comes to packet 4, initial QIC packet from the server with ACK and padding. Then packet 408, initial quick packet for client with padding and ping. And next is acknowledgement from the server, which is packet 409. Then packet 4010 is handshake from the server, and packet 401 to 4014 protected payloads from the server, and the 4015 handshake from the packet, and then the handshake with the client DC ID, and so does go on, that are protected payloads, right? Now let us discuss what is going in this screenshot. I know it's a very overwhelming information to see such large number of things at once, but let me just decrypt it for you. So the QUIC handshake. QUIC uses a 0 round trip, 0 RTT handshake, which means that data can be sent in the first packet itself. In other words, the client can send encrypted data along with the initial packet transmission, which saves time and improves performance. So as we have discussed this as in earlier slides as well, that it have a 0 RTT, which just means it can send hello as well. Let me just show you. See, the client completes hello in the first packet only. So this saves time. In other words, the client can encrypt data. So if we go back, you can see 0 RTTs was written there, which means that we have visited this website in recent times. As you can see, so which means like if you have visited a new website that you have never visited since some time ago, then it doesn't need to make a round trip for a connection handshake, which means the data can be sent in the first packet itself. Here, in other words, the client can send encrypted data along with the initial packet transmission, which will save both time and improve performance. Handshake starts with the client sending an initial packet to the server, which contains QIC client hello message. Then its version number, a random one, and a source connection, as you can see. Then we have DCID and SCID. DCID, there is, as you can see, this is DCID. Then the initial packet, before moving on, after we send the client hello message, it will contain a server hello handle. The server responds with the hello message that contain its one random nonce, selected cipher root, cipher suit, and the server certificate. After this, the client sends an encrypted message that includes the session ticket and buyer's initial data. We can see the servers respond on this diagram. Initial packet transmission. Now let's move on to the initial packet transmission. As you can see, the initial packet transmission is different from that in TCP. In TCP, the initial packet contains the SYN message or the single ACK message, whereas in QUIC, the initial packet of the client contains this difference. This is due to the fact that QUIC uses a zero round-trip time handshake, which eliminates the need for a separate synchronized message. Moving on to the next, other QIC specific parameters. QIC has several unique parameters that are used for encryption and flow control. These parameters include the encryption level, packet number, and flow control window. The encryption level is used to encrypt and decrypt the data sent between the client and the server. The packet number is used to ensure that the packets are received in order. The flow control window is used to regulate the flow of the data between the client and the server. To conclude QUIC tutorial, we can say that in conclusion, QUIC is a modern transport protocol that offers a significant improvement over traditional protocols such as TCP and UDP. We have discussed some of its features like encryption, multiplexing, flow control, and decryption. It also reduces latency, improves security, better performance in high congestion networks. We can see this has been rapidly gaining adoption by major web browsers, media streaming services, web services, and other network applications, making it a technology for the future of the internet. As with any new protocol, it is important to be aware of potential security threats. We have also discussed including the disadvantages of QIC. Overall, we can say that learning and implementing QIC can help developers and the network administrators create more efficient and secure network application that can operate and scale on the modern internet. With this, we are about to end this tutorial. Thank you very much for joining. I hope this was informative for you all.